All right, number 10 is no. Number 10 is no because BC would have to be parallel to DF for them to be similar through angle-angle similarity. It looks like it kind of sort of might be parallel, but it doesn't say it, so it's not true. So number 10 is no. I don't know, can you? Yes, you may. Okay. Number 12 is yes. It's all the reasons. Number 14 is no, because the angles of the triangles can never be congruent, so the triangles can't be similar, because math. Number 16 is they are similar, and 8 is what x equals. And 18 is 18. 20 is 15. 22 is 7.5 feet. And 24 is 10.75. Number 24. Is that the one y'all were fighting about? Okay.
Well, I lost my other paper, so.
All right. Number 24 is what we were saying. Okay, so number 24 says a some sort of tool. Hypsometer, as shown, can be used to estimate the height of a tree. I didn't know that's what that tool was called, but apparently it is. Bartolo looks through the straw to the top of the tree and obtains the readings given, or find the height of the tree. So the picture looks like this. We've got this triangle with the tree. We've got a right angle. We've got that the dude is 1.75 meters tall, or to his eye probably is what we're going to assume. And we are told this is X meters. And this right here is 15 meters.
Guys, the door wouldn't open, the lock got stuck. I thought I was going to die in there.
I'm glad you didn't die. That would have been sad. Oh, look, we also are given more than just that. That's good, because I was trying to think about how you would solve this without trig. Actually, I don't even know if you could solve it with just that without. Okay, so we also are given the hippometer, or whatever, hypsometer. Looks like this, something with probably a string, we're going to guess. And we are told this is 10 centimeters. We are told that this is AD, and we're also told that AD is like this. We're going to assume that these are parallel to this. And this is 6 centimeters. Excuse me. Okay. Is that what it looks like to y'all? Did I miss anything? We're doing 24. Oh, you're not talking about that. You're talking about something else. Okay, good. Glad everybody's fine. Okay. So what should we do? We are probably going to hope that there's some similar triangles, right? That's our hope. It also labels this as being a right angle. It's hard to see, but it labels that as being a right angle. Okay. I clearly didn't draw it to scale, but where are the similar triangles? Yeah, those right angles match, right? And the hypotenuses would be similar. So F, whatever that is, FG would go with is that H, yeah. FG would go with D, E, and E, F. Oh, that is F. Look, it's sitting right here. So, what proportion are we going to set up? 6/10 = 15. Sounds great. 6/10 equals 15/x. So when we cross multiply, we end up with 6x equals 150. And then x equals what now? 25. Oh, I know what the problem is. Maybe. We're about to find out in a second. You said 25? That sounds probably correct. And then if we added 1.75 to that, we'd end up with the tree is whatever that is, 26.75 meters tall. So there's a problem here. What is the problem?
I have no idea. What do you mean, what's the problem?
We did something wrong. We didn't account for something.
The 15? No, we didn't.
Looks to me like our units don't match.
Did you intentionally do that wrong?
No, I didn't intend. I think there's actually one other thing we did wrong.
Do I have to multiply it by either 10 or 0.10?
Yes. No, but you're on the right track. How many centimeters are in a meter? Not 10, but 100. So if we converted all the meters, it would be 1/10 of a meter, and this is going to end up with the same number if I'm not greatly mistaken, and we're still going to have a problem. So let's see if I'm right. So we would end up with 0.06 over 0.1 equals 15/x. So 0.06 equals 1.5, right? And then we divide that, and we end up with what? I suspect we're going to end up with the same thing, but go ahead and punch it. Yeah, 25. So it's still wrong. This is not a very well written problem, but I'm pretty sure that there's something else we did wrong, and I'm pretty sure I know what it is. But do you know what it is? Trying to think about any way that, how would we know that this is the problem? Because I think the problem is, punch it in this way. Let's do it this way and see if we get the right answer. We're looking for an answer of what, 9, right? Ultimately. Punch it in this way and see what happens. So that'd be 10x equals, what is that, 60? No, it's not 60. That's a lie. How about 75? No. It'd be 30 to 90, right? That's right? And that you probably don't even have to punch in. We end up with x equals 9. And then we add the 1.75 and end up with a total height of 10.75 meters. So let's see. See if we can think. Let's see if we can think through a way to make it obvious that that's what you would have to do. We have, this is AD, right? AD. And then F is right here. Oh no, AD is not like that, is it? Because F is shared, right? Because this is F. AD is up here. So it's actually this shape. Is that right? Does that look right? Is that where the 90 degrees is on there? These two would be parallel if we assume how this works correctly. Which doesn't necessarily. I don't know how this one would be obvious that that's how we would do this. I'm trying to give them the benefit of the doubt and come up with something, but I'm coming up empty. Are y'all seeing something that I'm not seeing? Because what we would be trying to essentially figure out is that this side, this one corresponds to this one. Yeah, these can't be. This is not going to be one whole angle, is it? Can't be. Because that can't be a right angle on that one if this is the same line. So this actually is sitting like not parallel with this. This line, the EF, is not parallel to whatever that is. FG. There's no way it can be. That's why you got the answer wrong. And I'm not sure how you would have figured that out without having the answer. So Merry Christmas. You won't have a problem exactly like that on the test. How's that sound? Good. Okay. But that's why it ends up that way. Any other questions on the homework? No.
No, but I have test corrections to turn in.
Okay, I'll take those. What did you do to your ankle? I assume ankle.
Yeah, I was doing a back tug yesterday and I landed wrong, so I had to go to urgent care or whatever, and then get x-rays. But nothing is broken, which is good. But it's my Achilles or something like that. I don't really understand what they said. So they said that it's really bad or something, and that I need to be careful because it she said that she can feel something in my foot or something, and that if I'm not careful, it can turn into a tear, which is a long recovery, which I don't want to do because then I will be sitting out for like a long time.
So you got to keep it braced and careful and all that stuff.
Yeah. So they gave me
You were doing. You said you were doing a back tuck. Is that what you said? You do gymnastics?
I tumble, yeah.
Oh, okay. I didn't know that. I don't know how I didn't know that, but I didn't. I don't know. All these other people do volleyball, so you know.
Are y'all doing volleyball this year? Yeah. Probably. Why aren't you? My back is like so broken.
Because she's a crooked lady.
I started volleyball too. With all the new people, I keep up pretty well, but you'll get there. Hopefully.
So, do y'all have while I write this title, do y'all have plans for what you're going to do for math next year?
No, I'm done.
You're done. How could you possibly be done?
Well, I mean, there's college algebra, but I won't take that when I'm in university. 'Cause I already did algebra 2.
I wouldn't take a year off if it were me. I would do something, even if it's just doing Khan Academy practice or something. That way you don't, it doesn't all ooze out your ears. You can do what you want, but I wouldn't take a year off of math and then hope to do really well on the college algebra thing. It's probably a bad idea. Y'all are, what grades are y'all going into? Juniors? Senior? You sound real thrilled about it. A junior. So are you planning to take Algebra 2 somewhere, something? Probably. Okay. Well, registration's open for our classes. I do think all of y'all will enjoy Algebra 2 more than geometry. I think y'all are more algebra people than geometry people.
100%. I hate shapes. They scarred me.
They scarred you.
This class scarred me.
It's going to be okay.
I hate looking at them.
Sure. Parts.
Like this rectangle table right here is just.
But can you prove it's a rectangle?
And that's exactly why it's.
Exactly. Parallel lines and proportional parts.
It smells like something burnt.
What?
It does smell good. It smells weird though.
What smells good? What are you saying?
It smells like pizza. Yeah.
They were making pizza in there, so that's probably why.
Probably what it is. That's like.
They're making pizza or something in there. All right, so triangle proportionality theorem deals with a triangle.
Here a second, please.
Good Lord, girl, it's been up there for like 35 years.
Pay attention.
Yeah. That wasn't even shapes, that was words.
Well,
Well. Did you just say iCarly something? Is that even a thing anymore? Nobody knows.
Whoa, I definitely did this wrong.
Good job. So proud. So the triangle proportionality theorem says that if BE, we've kind of already seen this in action a little bit. We're officially writing it, is parallel to CD, then AB, the measure of AB, over the measure of BC equals the measure of AE over the measure of ED. So if those sides are parallel and they have a included angle, right? Included angle A, then their sides are proportional.
What is that, like, under the AB, what is that, a DZ or a D what? What's like
Yeah, it's totally a Z. There's totally Z's everywhere else.
what is it really?
It's a B, C. But what this, I don't know if we've realized what's happening or not, but it's not quite that the sides are proportional. It's one more thing that is proportional. So we have one more thing because AB is right here, right? And AC are right here, so that's these sides together. Should have changed colors. Don't know why I didn't. Meant to. There it is. Does it even look different on that screen? Only barely. Okay. AE. Did I label something wrong? AE, BC. Oh, I did. Why did I write AC?
That's what I asked.
I didn't write AC. I had it right, and then you asked something about a Z.
You were rewriting it, and then
I
you said that,
what?
and I said, why did you write that? And
Oh.
then I said, whatever.
Well, I didn't hear that conversation that we apparently had that I wasn't involved in.
I said whatever, because you weren't answering, so I was like, whatever.
I didn't hear you. Calm down.
Sorry, I thought you were ignoring
BC is right. I wasn't ignoring you. I don't usually do that intentionally. Y'all ignore me all the time, but I don't ignore y'all.
Good for you.
Rude. So, AE is here, right? And then ED is right here, right? So it lets us relate those little segments on the end as well, because those are also proportional. Right? So that's what this theorem allows us to do. It gives us one more group of proportional segments. Let's do an example. Okay. In triangle PQR, ST is parallel to RQ if the measure of PT equals 7.5, TQ, the measure of TQ equals 3, and the measure of SR equals 2.5. Find the measure of PS. And this is the triangle we're looking at. It's probably going to be warm today.
Maybe your dogs will get out and you should chase them.
Then I'll put some shorts on.
I'm not gonna chase them in sweat. Long buttons out and flip them.
Okay. So, what should we do to solve this thing?
What?
What should we do to solve this thing? That's what.
We should. Yeah.
I'd label it first so I can, because I am definitely auditory, but on these kind of things, it's helpful to have where things actually belong. So where is PT? I think you mean left. And then where is TQ?
Beside it.
And then SR?
Very bottom. On the left.
And then PS. So then, yeah, we should set up a proportion. So what's the proportion going to look like?
X over 2.5 equals 7.5
And then we're going to solve the thing. So x times 3 is 3x. 2.5 times 7.5 is what? So close, but no. Y'all have calculators.
15.
No.
16.5.
No. 18.75. What are we going to do now? Divide by 3. So x equals what? There it is. Let's do another problem using the converse of that theorem. In triangle DEF, the measure of EH equals 3. The measure of HF equals 9. And the measure of DG is 1/3. The length of the measure of GF. And we want to know is DE parallel GH. And our picture looks like this. Okay, so what should we do?
Set up proportion. Actually, label. You
Okay.
label first.
Where's EH?
Hang on, I need to draw the picture first.
Where's HF? And the measure of DG is 1/3 the measure of GF. Right? Right. And we want to know if they are parallel. So what can we do to figure that out? You said set a proportion. I think that sounds like a great idea.
Yay me. I don't know. What is that R? Okay. I'm gonna do. I don't even know.
If this is X,
Where's the GF?
it's right here. If that's X, then what would GF be equal to? 3X, right? So let's set up a proportion.
X over 3X equals 3/9, I think. Right?
Perfect. It's totally right.
Yeah. I know.
And we need to see if this works out. So what are we going to do? What's X times 9? 9X equals 9X. So X equals X, or 1 equals 1, or 9 equals 9. Any of those we could get to from there, right? Any of those are true, so the answer is yes. Because this stuff. How's that sound? Reasonable? Okay, another theorem. Whoop. Triangle midsegment theorem. So we've got to remember from a couple of units ago, what is a midsegment of a triangle?
Where they meet in the middle.
Remember, there's like 3 or 4 of those. There's like the orthocenter and the circumcenter and all the things. Which one is the midsegment? You may need to go back in your notes to remember. Oh, we didn't talk about what, just kidding. LOL, JK, that's not a part of what we talked about. You're not going to have to remember anything. Come back to me. So here's the mid segments. You ready? These are the mid segments of triangle ABC. Right? If I said, what is the midpoint of this? No, that's stupid. The mid segments are where all the midpoints are connected. So these are the mid segments of those triangles. So if those are mid segments, then these are congruent, right? These are congruent, and these are congruent. Those are what mid segments are. Illuminati confirmed. Triangle mid-segment theorem says, we'll write the words part and then we'll draw the picture. If J and K are mid-segments, mid-points. That makes so much more sense because those are just letters. Of, I know, I ruined your life. You need some white out. So sad. FH and HG that's unusual. Usually when I look out of the corner of my eye, I think there's a person there. It's a bush. But this time it was a person. Oh, no. That's not really that scary. It's just Sarah. It's okay. She appeared to be on the phone. HG, respectively.
Does it actually say that in the book?
Yeah, so that in English you want to do that. So like J is the midpoint of FH and K is the mid segment of HG. That's what that means. So like it means that the order, you match the first order to the second order when you see that. Not respectfully, that's a different word, but respectively. Respectively, then, yeah, I know even what you're thinking. Then JK is parallel to FG and the measure of JK is half of the measure of FG. Let's draw the picture so we can know what the heck is happening, right? So if we have this triangle, and we have the triangle FGH, and J is the midpoint of FH, which means that this and that are congruent, right? And K is the midpoint of GH, HG, either way. JK, LOL. Then what this is telling us is that segment JK, that mid segment, is parallel to the side opposite. True facts. Yup. It also tells us this guy, that this is half of that length. Make sense? Let's see with an example. Well, yeah. In the figure, xy and xz are mid segments, not points. And we're going to find the following measures. Okay, so the triangles we have look something like this. This is 124 degrees. And this is 13. So we're going to find the measure of xz to begin with. Okay. So we're finding the measure of xz, so what should we do? What are y'all?
Measure 120 or 124?
That's 124. OMG. So, how are we going to find the measure of xz? No, not the degrees. Definitely, yeah, that'd be the other option.
1/2 of RT.
It is 1/2 of RT, and we know that because of the mid-segment theorem. Right? So we can set up the measure of xz equals 1/2 the measure of RT, right? We know RT is 13. So what we're interested in is half of 13.
So it's 6.5?
So it's 6.5. All right, so the second one we're going to do with this shape and these instructions is we're going to find the measure of ST. Okay, so how are we going to do that?
Is ZT the same as RT?
No.
2 times 7?
Yeah, so we're using the fact that this is also a mid-segment, so the measure of XY is 1/2 the measure of ST. And we know XY is 7. And so to get rid of that 1/2, we'd multiply. So what's the measure of ST? 14. And finally, number 3, we're going to find the measure of angle RYX. So where is that angle? Yeah, it is at the bottom. RYX, so this guy right here. So how are we going to do that? Definitely the degrees this time. Definitely. They are alternate interior because the mid-segment theorem says that this line is parallel to that line, which means the alternate interior are congruent, therefore 124 degrees.
Are we done now?
Are we done now?
Seriously though.
Seriously, though.
Are you going to answer? I thought you said you didn't ignore us.
What?
I said I thought you said you didn't ignore us, so why are you answering?
I did ignore. You're right. I'm sorry. No, we're not done now. Proportional parts of parallel lines. It's going to be okay, girl. It's going to be okay. We won't end class early every time.
Are you talking to her or me?
You.
Because one thinks she wants to get out of here too.
True. True. Are you feeling picked on? Do you need a lollipop?
That would be great.
Sure. Yeah. Of course. Why not? Yeah. That's the whole do you want a cookie? Like, what kind of stupid thing is that? Of course I want a cookie. Why are you asking me something dumb? Facts. Actually, I'm not a big cookie person, but still, the phrase is dumb. This is the last theorem we're going to talk about, and then we will be done. How lovely. So, if we have this kind of setup where we have 3 or more parallel lines, this would be true no matter how many parallel lines you have, crossed by a couple of transversals. Then we're gonna write this again. This would stack. You could Jacob's ladder this up on to infinity, and it would work for all of the little segments. So we're gonna write it like this: if AE.
Why is there 2 E's?
Because that one's an F. Thank you.
You're welcome.
If AE is parallel to BF is parallel to CG, and again, this could stretch on forever, then These little segments are proportional. The measure of AB over the measure of BC equals the measure of EF over the measure of FG. We're going to do a problem where it's find X and Y. And this is what our shape is going to look like. This is 6x minus 5. This one is 4x plus 3. And this one is 3y plus 8. And this one is 5y minus 7. And this problem would be impossible if we didn't also know that this segment is equal to that segment. Okay. What? How are they equal if they're different? What are you saying? Those segments are equal. The expressions are not the same expressions. We've been doing things like that for a long time.
Are we done now?
No, we got to solve this problem. We got to solve for X and Y. So, what are we going to do to solve for X and Y? The hint I will give you is we got to solve for Y first.
We have to set up an equation.
We do have to set up an equation.
3y plus 8 equals 5y minus 7.
Yes. Equals 5y minus 7. Then we're going to solve for y.
7, which gets negative 1. That's 2y.
It doesn't equal negative 1. You're a liar.
I'm not talking about the 3.
I know. I'm talking about what you just said. You're a liar.
1
It doesn't equal 1.
equals negative 6.
It doesn't equal negative 6.
9. I suck at negatives. Oh, 8, 9, 10, 11, 12, 13, 14, 15. Wait, what?
Negative 15. Yeah.
Negative 15.
Negative 15. True facts. And then last step there, I'm going to divide by negative 2, and we end up with y equals 7.5. So that's part of our answer. Now we need to solve for x. But in order to solve for x,
5 equals 4x plus 3, I think.
no,
What?
we're not given that those are equal. In fact, they probably aren't. Well, we should probably use the theorem we just learned. But first of all, we need to figure out what these lengths are. So how would we figure out what this length right here is at this point?
You're going to do 3 times 7.5 plus 8.
Okay, do it. 30.5. And then what is this little section right here? What? Or you know what? They are equal. You're right. Because if those are equal and they're proportional, then those are equal too. Because if we were to set up a proportion, it would be 30.5 over 30.5 equals that one. So yeah, you're right. We can set up that exact same equation, but with the x ones. So 6x minus...
More often.
I shouldn't I? Especially when you break your foot. You seem to get more intelligible after that. You could have responded with, "It's not broken, genius." That's what I told you earlier. Or you could have made it a nicer version of that. So what do we end up with solving there?
-5 or -5 from the 3.
Yeah, and minus the 4x, and so we end up with 2x equals 8. X equals 4. Homework. Finally. Oh my gosh, I'm trying to leave.
Time to.
Exactly. Look how talented I am.
It's not talent.
Do I need to come over there and punch you in the face? No, I would not get sued if the people were being wise. What I would get is press charges against them, probably go to jail. Which would be not very good, would it?
Could be worse.
It would be, exactly. Exactly. Pages 496 through 497. Numbers 14 through 26 evens. Goodbye. Have a nice few days. See you Wednesday, Thursday, whenever this